Okay, now we're going to sketch a graph with a horizontal translation, a vertical translation, and an amplitude change, right? So if you need to modify this equation to view it a little differently, that's fine. Meaning if you take this -2 here and put it to the right side, that's fine. So I kind of like to do it that way. So if I add 2 to both sides, I get y equals 3 sine of x minus pi over 2. Right, and then plus 2. So in this case, the angular frequency doesn't really show up as a value, which means it's 1. And then I just go through and identify critical parts. So my A value is 3, which means my amplitude is 3. My H value is pi over 2. My K value is positive 2. And my angular frequency, my B value, is going to be 1 right now. So if your angular frequency is 1, then your period is going to be 2 pi. And that's because of this relationship. Period times angular frequency is 2 pi. Therefore, if B is 1, then the period has to be 2 pi. Now, when we graph, we want to focus on the scale, right? So that's where we take 1/4 of the period, find our scale. 1/4 of the period, which means we're taking 1/4 of 2 pi, right? So that's 2 pi divided by 4, which is going to be pi over 2. Right? So our scale that we want to use here is pi over 2. But we have to, well, in this case, it kind of works out. So you want to focus on the scale you're going to use, but you also want to look over here at the H value. In this case, both have the same denominator, so it's going to work out nice for us. It's when the scale identified is an unlike denominator with the H value, right? So we want to use common denominators for the scale if the H value and the scale you identified don't match, which we'll get into that example in a second. But because my scale is pi over 2, I'm just going to start marking pieces by pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, and so on. So this is pi over 2. This is 2 pi over 2, and so on. Over here, negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2. Negative 2 pi over 2 is really negative pi, right? And my amplitude is 3. I just want to give myself enough space here. So 1, 2, 3. And down below, give myself enough space down below here. Give me 1 second. And I just need to make more space on my screen. So then we'll go through and mark that y-axis with the scale. And then we'll get into graphing. So -1, -2, -3 here. Looking back at my function, this is a sine function, right? Remember, sine starts line of oscillation and runs up and down, especially if the A value is positive, which it is in this case. But when you go to graph this, you kind of want to look at your K value, right? So I started making my scale and I wasn't paying attention to my K value, which is 2. So if I use the scale I created on the y-axis right now for 2, I don't have enough space to graph the high point on my curve. So I'm going to back up here. I'm going to change my scale. And this is stuff you have to do and think about as you're doing it. So what I'm going to do is I'm going to go back to a scale of 1 in this case. So 1, 2, 3, 4, 5, 6, and so on. -1, -2, -3, -4, -5, -6. Okay. I always like to put my line of oscillation in, which we said was K equals 2 right here. So I'm going to just sketch that in, horizontal line, give me something to look at as I'm sketching, right? And then, our starting point is h, which is pi over 2 radians, which is right here. So I'm going to use pi over 2 radians. And it's going to start at the line of oscillation right here. And then we're going to move 1/4 of a period and move to a high point, right? So right now, this green point that you see on the board is similar to that starting point on that cycle. The next point I put on the board is going to be a high point. So I'm going to move 1/4 of a period over. So I'm going to move from pi over 2 to 2 pi over 2. And my high point, right now my amplitude is 3, so I have to move up 3 units. 1, 2, 3, and I am 1/4 of a period over right here. And then another quarter period over, I'm back down to the line of oscillation. Another quarter period over, I am down 3 more units right here. Another quarter of a period over, I am up back to the line of oscillation. This is one complete wave at this point, right? And then I'm going to balance this more on the left side as well. So I'm going to start moving to the left from my starting point here. 1/4 of the period over, I'm going down to the low. Another quarter of the period over, I'm back up to the line of oscillation. Another quarter of the period over, I'm back up at a high point. And another quarter of the period over, I'm back down to the line of oscillation. Like that. And there are 2 full periods of the sine graph. We just had to look at right there. Not too complicated, but you definitely have to practice it and think about it. We're going to jump to this next example here, which is actually already graphed for us. So let's take a look at the information we have. Sine function, right? So remember, sine starts at the line of oscillation and increases. It's always good to just give yourself a visual again, receiving it regularly, right? And it's going to look like this because the A value right here is positive. So A is 2. My K value is 3. I can see that in my equation right here, right? K is 3. My H value, be careful, this is an addition of pi over 3. So that means my H value right here is negative pi over 3. Period can be found from your angular frequency, which is your B value. So B right now is equal to 1 because you don't really see a value inside that sine function being multiplied to this group here, x plus pi over 3. So B is 1, which makes the period 2 pi. And then I'm going to take 1/4 of 2 pi to scale this, right? So for the scale, it's 1/4 of the period, 1/4 times 2 pi leaves me with pi over 2, right? That's my scale, which is right here, right? So I want to scale by pi over 2. But this is where we have to pay attention. The H value is pi over 3. And those are unlike denominators. So in some cases, you're going to have a hard time finding the exact location of this H value, pi over 3, if your scale is going by pi over 2s. So the way you can correct that is you're going to use the denominator of each of these, pi over 3 and pi over 2, and you're going to work with the least common denominator there, which is going to be pi over 6. So we want to scale not by pi over 2, but by pi over 6 to accommodate for this pi over 3h value and the scale, helpful scale of pi over 2. So multiples of pi over 6, right, will give us pi over 3s, and multiples of pi over 6 will also give us pi over 2s. So pi over 6 is the logical approach. So each tick mark here horizontally is 1 pi over 6, right? So counting them, 1 pi over 6, 2 pi over 6, 3 pi over 6 simplifies to pi over 2, right? And then I can also find pi over 3 because 1 pi over 6 right here, 2 pi over 6 simplifies to pi over 3. Right? So that's, you want to pay attention, again, when the scale that you identified from the period is in a different denominator than the H value, use the common denominator, and that'll allow for a much easier graphing. Next up, my K value. So I'm going to list the scale on my x-axis. The scale on my y-axis is going to stay by 1s. My K value is 3, right? So I'm going to jump up here. and sketch this line of oscillation in at y equals 3. And at that point, I want to locate where this negative pi over 3 starting point is, right? So you're going by pi over 6 is, right? Negative 1 pi over 6, negative 2 pi over 6 is negative pi over 3. So that means right up here is where I want to start my sine graph. And once you've identified that location, it's just a matter of moving 1/4 of the way through the period, right? So now 1/4 of the way through the period is now in pi over 2s, right? So you have to be careful when you do that. So sometimes it's good. It's a good sense to just get us, if you're using different scales, right? 3 hash marks here is equivalent to pi over 2, which is the scale we want to move to next critical values. Or you just count by pi over 6s again, but I think it's easier to just identify that 3 hash marks here is 1/4 of the period. And that's how we're going to graph our next one. So starting here, sine starts at a line of oscillation and goes up to a high point. The amplitude is 2. So it's going to increase two vertical values as it moves 3 hash marks to the right, which is pi over 2 radians. And here's the next one right here. And then I'm going to move 3 more hash marks to the right, which is pi over 2 radians, which is 1/4 of a period. That's my next point right here. And I'm back down at the line of oscillation. I'm going to continue to dip down. So I move another 1/4 of the period over, go down 2 units to a low point, move 1/4 of the period over, and we're right here again. And now we've kind of sketched one full cycle, right? So based on the space I have available to me, you just want to make sure your graph covers 2 full periods at this point. So I just continue from this point here to move, over to my next high point and my next low point. That covers half of a period right there, that extra piece that I just went. So this is 1/2 of the period. And then I'm going to kind of do the same over here. That'll cover 2 full periods. So again, from your starting point here, I'm going to move to another low point over here and another line of oscillation. This is another half of a period, giving me 2 full periods on the graph. The tricky part here in this case, once you really understand how to graph, is just addressing this how you want to scale your x-axis if the 1/4 of a period is in a different denominator than your starting h value there, which is a common denominator. And be careful, don't rush through it, and you're going to practice more of these.